Okay, so we're working on Chapter 5, Section 4, 5.4. We are factoring and solving polynomial equations. Our objective for today is to solve polynomial equations and equations involving rational expressions. So what we're doing is, this is a new topic. This is probably going to be new for most of you. You may have done a little bit of this in Algebra 1, but probably not enough for you to remember it. A couple of these terms may be new, and we're going to go through a couple of examples. Hopefully, it's not a major deal. By the end of the class today, or the end of this note session, I am going to show you how to use the graphing calculator a little bit to your advantage when solving these things. So let's get to it with the vocabulary. The main thing that we're going to talk about with solving and factoring polynomial equations is a technique called factoring by grouping. It's just a technique used to factor certain polynomials that have common monomial factors, and you will see what we're talking about when we get there. Another term is quadratic form. The quadratic form is an expression of the form au squared plus bu plus c. That's just pretty basic. We've talked about that many times. And then the very last thing is, a polynomial is factored completely. If it is written as a product of unfactorable polynomials. In other words, if you cannot factor it, if you can't break it down any more, then it is factored completely. So you will see that term come up pretty often when someone's teaching it to you, or maybe when I'm saying it. When I say it's factored completely, it means it can't be broken down anymore. So let's review real quick. Let's review how to factor a quadratic. And I'm going to run through this very quickly. When we're factoring, I know that we struggled on this a little bit in the chapter 4, but when we're factoring, we always look at this front term. And we're going to set this up. When we FOIL, 2x times x is 2x squared. That's why I know to set these parentheses up like that. The last two terms have to multiply to be this -4. Now, we're not going to go through and do all these tests because I already know what it's going to be, but the idea is that when I put these numbers in here, you know that 1 times -4 has to equal -4. You know that 2x times x has to equal 2x squared. And then all we're doing from there is just checking it to FOIL it to make sure that this middle term works out. So we would do 2x times x is 2x squared. We do 2x times -4 is -8x. We do positive 1 times x is positive 1x. And 1 times -4 is -4. And what you notice is these middle terms do add up to be -7x. So these are the correct factors. So this is good. Now, moving on to when we have something that's not just squared. The one thing that we have to remember is the first thing you should always look for before factoring is there a common factor in the polynomial that we have? And if you notice here, we have x to the third, we have x squared, and we have x. Well, there is a common factor. There's a common factor of x. There's no constant here. So because of that, we want to bring an x out to the outside first. That's the first thing we do. So if we've pulled an x off of our x to the third, that will now be x squared. If we've pulled an x off of x squared, that will now just be x. And if we've pulled an x off of our 10, then that will just be 10. So what we did was we first factored out an x. Now we're left with a quadratic on the inside that we can still factor. So we have x on the outside, and then we go ahead and set up our other two parentheses. Because it's just x squared, we know it's just going to be x out front. And now because it's just x squared, we're looking for factors of 10 that will add up to be -7. So here I know factors of 10 are 5 and 2, but also -5 and -2. And -5 and -2 do add up to be -7, so those are our factors. Okay, so that's a quick review there. Again, the major thing there is knowing that you need to be able to factor out common factors first. That's very important. Okay, let's talk about a couple of simple rules. Again, you don't have to memorize these rules, but if you do, it just helps you a little bit to get this done a little bit faster. But before we do that, we're going to fill out a table here of all of our cubes. So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and then 10 cubed is 1,000. Now you don't have to memorize these, but we're going to use these in these rules that we have. So we're talking about factoring the sum and difference of cubes. We've talked about factoring the sum and difference of squares, but this is going to be with cubes. So what they're saying is if we have a cubed plus b cubed, we will get the general form that looks like this. If we have a cubed minus b cubed, we will get the general form like this. So what this means is that when we take our a to the third or b to the third, what we're going to do in these examples is the coefficient is included in that. So when I look at 27x to the third, it's not, our a is not x. Our a is actually part of the 27 as well. So that's why we did this chart over here. So you can see that 3 cubed is 27. So it's the entire thing. So how we write this is 3x, the entire thing cubed. And then over here we have 125. If you look over here, that means it's 5 cubed. So that will be the quantity 3x cubed plus 5 cubed. So using the form from above, we know that our a is 3x and our b is 5. So now we can set up our factors here like this. 3x plus 5, because they said the first one is just a plus b, that's a plus b. And then we fill in the rest. A squared, which 3x squared, or 3x times 3x, is 9x squared, minus a times b, so 3x times 5 is 15x, plus b squared, which is just 5, which is 25. And that's it. So those are those factors. Now, the second one is we have d cubed, so we know that it's just going to be d cubed minus, and then 125 is still going to be 5 cubed. So this is going to be the difference of cubes. So again, set it up exactly as is. A minus b. Our a is d, our b is 5. So our first factor is just going to be d minus 5. And then we just follow along. A squared is going to be d squared, because d is a. Then we do plus a times b. So our a and our b is d and 5, so it's going to be plus 5d. And then the last part is plus b squared, our b is 5, so 5 squared is 25. And that is it for those. Okay, moving on. Here's going to be where the real new concept is, the factor by grouping. So you can read through this for what factor by grouping is, but essentially what's going to happen is if we have 4 terms, typically, what's going to happen is sometimes we can factor by grouping. And factoring by grouping it's pretty interesting. What's going to happen is when we say we're grouping, what we're doing is we're taking the first 2 terms and the second 2 terms and grouping them together. So in this example right here, I'll let you read through this example on your own, but let's just get right into the examples that we have. What we're going to do is we are going to group these 2 together. Make sure you include the signs. So notice that positive sign is there, which doesn't matter because it's positive. So now what we're going to do is now that we have these grouped, we are going to now take out common factors from each one. So here we have x to the third and x squared. Well, the greatest common factor of that is x squared. So what happens is we have x squared on the outside because we pulled an x squared from both terms. And here's what we're left with. Because we had x to the third and we pulled an x squared off of it, we're still left with 1x. Okay? And on the second one, because we pulled the entire x squared out, we're left with plus 1. So that's the first one. The second one is x plus 1. That cannot be factored any more than what it already is. So it's going to be plus, and then we're going to leave a 1 on the outside because we're just going to factor out a 1. And then the x plus 1 is going to be on the inside. So anytime you can't factor anything to the outside, you can just put 1. So now what we're going to do is, when we factor by grouping, now what happens is this term, and this term will become one of our factors. X squared plus 1. And then our 2, the ones ones that are left are going to be our other term, okay? But they're only one term. We're not going to put x plus 1 twice. We're just going to put it once. So that is factored. This cannot be factored anymore, so it's done. X squared plus 1 times the quantity x plus 1. That's factored. Okay, next one. This is going to be a little bit different, but it's the same concept. We group these into two groups, and then we pull out common factors. So the common factor of this first one, 25s to the third minus 100s squared, the common factor here is not only is it s squared, but it's also 25. So the 25s squared will be on the outside. We will be left with s minus 4 on the inside. On the other one, we have a negative out front. So we're going to pull the negative out to the outside. So now what we're left with on the inside is s minus 4. So one of the things about this is we need to understand how to pull monomial terms out. So again, because we pulled the minus out of here, the minus is right there. It's just a minus, so we are going to put a 1 there again. And we're left with s minus 4. Notice, it's s minus 4 because when we pulled the negative out, we're pulling the negative off the s and we're pulling a negative off of the 4, which means it now needs to become the opposite of what it was before. Negative 1 times negative 4 is positive 4. So now that we've pulled all this stuff out, again, it works the same. We have 25s squared and negative 1. So our first factor is 25s squared minus 1. And our other factor is just s minus 4. Now, the only problem about this is that this one can still be factored. This is a difference of squares. And without going into a lot of detail, because we've talked about it before, this factors to be 5s minus 1 times 5s plus 1. And then our last one is still s minus 4. So we have three factors there now that have now been fully factored. This is completely factored using our factoring by grouping. So in this last one, we're going to go through this pretty quickly. I'm not going to show you how to factor by grouping again. What we're going to do is I'm just going to show you what our final result here would be. And I want to make sure we recall and understand what the zero product property means. And then what I'm going to do is I'm going to pull up a program and show you how to solve this in the calculator. So here's what our factors are. So hopefully we understand when we factor completely, the zero product property helps you solve equations. So once we factor, because it's equal to 0, we can simply say what our solutions are. G equals negative 1, G equals 1, and G equals negative 3. So that works here. But what I also want to do is I'm going to show you how to use a graphing calculator to solve these two. So maybe if you don't know how to factor that well, you can use the graphing calculator to do it as well. So we're going to open up this program and show you how to do that. So as you can see, is I have the graphing calculator pulled up, and in the y equals, I have our equation. So you can see the graph here, but I'm going to go ahead and click on the graph, so that way you can see a bigger version of the graph. Okay, there it goes. So here's what we're going to do. Real quickly, you can rewind this if you need to. I'm going to show you how you find the zeros. Because all the values we said, G is negative 3, G is negative 1, and G is positive 1 are all your x-intercepts. That's what solutions are your x-intercepts. So how do we do that using the calculator? Well, if we wanted to solve those or find out exactly what those values are, we hit second, calc. We go to 0, the second one down, hit enter, and then we actually just go through the calculator, and it says left bound, which means we want to go to the left of where that 0 is. So now we're to the left. I know it's underneath, but it's to the left. You hit enter, and then you go above, and you will see it again for the right bound, and then the guess, you just hit enter a third time, and you will show that it shows x equals negative 3. So I'm not going to show you the other two. We're going to do more of this in class because we're running out of time here. So that is how you use the calculator to find your zeros.